Hi, welcome to Interpreting Electric Meter Data, or it's 10 p.m. Do you know what your power is doing? Presentation series sponsored by Better Bricks. This training is broken down into 5 parts. This is part number 3, what is interval data and how do you get it? In this session, we'll be covering data, what is interval data, and the data collection, when to do it, and how do you get it. So let's talk about interval data. So what is it? Well, energy usage data that is time-stamped in intervals. So technically, your monthly bill is interval data, but the interval is somewhat less than desired. It has an interval of 28 to 33 days, depending on the month and the billing cycle. So the data is much more meaningful in intervals of 1 hour or less. 15-minute interval data is probably the smallest increment you will need. So before analyzing your interval data, you need to know a number of things about the data. Some things to watch for are the timestamp. What's marking the time? What is setting the timestamping clock? Is the time in universal time, local time, or daylight savings time? What happens when the time changes between daylight savings time and universal time or local time? Also, if you're comparing the time to equipment run and stop times, what is setting the time for those? If somebody's writing in a log when they started a piece of equipment and you're using that to look back at your interval data, what clock are they using? What about data backups? If you have interval data, maybe you're getting it from your energy information system from your building. Maybe it's from the building management system itself. But how is that data being backed up? Is it being archived? How long is it kept? And how accessible is that data? And what are the units? Are the units in kW or kilowatt hour? If it's a demand in kW, are these values in instantaneous demand? For example, a lot of weather stations will take the temperature and they'll take it 3 times an hour, but they may report the temperature as being the highest during that hour, or they may average all 3 readings together. So the same thing with energy usage. You need to know, is it instantaneous value? You sampled it at 12 noon and that's the value you're using. So the next question is well, when do you need to collect interval data? It can help you answer lots of questions. For example, does my load profile match my operating hours? Are my heating, ventilation, and air conditioning system timers programmed correctly? When do I use the most energy? How can I identify problems before I get the bill? Did my energy improvements save what was expected? Is my base load normal for my facility? When did something change to cause a 15% increase in my load? How does weather affect my operations? Can I save money by reducing peaks or reducing my base load? If you have questions like this, then you need to have interval data, and you need to collect it, understand it, and interpret it. So the next question is, when do I do it? Do I do it on every building, every meter? The U.S. Department of Energy has a publication called the Guidance for Electric Metering in Federal Buildings. Listed here is the website where you can go to get that information. It's got some great information on deciding when to do short-term, long-term, or one-time spot measurements. So you may be trying to figure out what is the minimum annual electric bill before I should consider installing some long-term advanced metering. So here are some things you need to know. What do you expect the savings to be? What is the desired payback? What are the installed costs? And are there any annual costs that go along with what I'm installing? Once you have that information, here are some different assumptions that you can take a look at. So first of all, what should you expect in savings? These come from the U.S. Department of Energy publication that we just spoke about. So first of all, what are you going to do with the information? So if you're metering, here are some of the savings ranges that have been observed. So if you're just going to use bill allocation only, for example, you're a facility and you have multiple people using that, maybe it's a manufacturing facility, maybe it's an office building, and you allocate the bill to the people that are actually using the energy. So in the case of a manufacturing facility, and you're working on the assembly section, then the manager who's responsible for assembly is the one who pays the bill for that part. The shipping and receiving place and the warehouse people are responsible for the energy use in those areas. So typically, the observed savings for just allocating the bill out to those users is a 2.5% to 5% observed savings, and that's mainly from improved awareness of what the things cost and them being held responsible for those costs. The next step up is doing a building tune-up, and due to the improved awareness and identification of simple operations and maintenance improvements, the observed savings for that ranges between 5 to 15%. The next action would be continuous commissioning. In this case, the improved awareness, the identification of the simple operations and maintenance improvements, looking at project accomplishment and continuous commissioning can have an observed savings of between 15 to 45%. And that's based on, again, the improved awareness, the identification of simple O&M improvements, project accomplishment, and continuing management attention can really help to boost your savings. So let's look at what it should cost. So if you're getting your system from your utility, typically the installation or software and hardware costs run between $100 and $500, and the cost for a hosted system or the internal labor annually can be anywhere from $0 to $800. If you're installing your own system, the installation costs for software and hardware are quite a bit more, between $1,500 and $3,500. Now this is sample pricing only, and it's not meant to be indicative of what's available in your area. So when we go back to some calculations that are provided in this reference guide that we talked about, we take our installed costs and divide that by our desired simple payback, plus what the annual cost is, and divide that by your annual savings. And the annual savings is in a percentage of annual savings. And that'll provide you with a rough idea of what the minimum annual electric bill should be to get your payback. So in this case, we're going to use a savings assumption of 2%, a payback desired of 3 years, an annual cost of $600 a year, with installed costs of $1,500. So in this case, you plug those numbers in and come up with a value of $55,000 annually, or approximately $4,600 a month. So you can take a look at your electric bill based on those assumptions and say, if my electric bill is less than $4,600 a month, then I shouldn't spend time or the money to put in a metering system to track my interval data. So from this calculation, we've found out that your average annual electric bill should be about $55,000 or about $4,600 per month. If your energy usage is calculated to be higher than $55,000 annually, or approximately $4,600 a month, then you would want to implement the steps necessary to get interval data. So now you've decided that you need to have interval data, where are you going to get it? Well, there are a number of different locations. First of all, check with your local utility. Many of them now are installing smart metering systems and having that interval data already that they're collecting, and will be able to provide it at a reasonable cost. But there are lots of other ideas. You may have an energy service supplier that also will have this information. Your energy management system that's keeping track of your building may have some of this information being recorded already. Your heating, ventilation, and air conditioning system may also have inputs that are calculating or showing when certain things turn on and off, and they may also have meters that are calculating the energy usage. There are also third-party providers out there that you can search on either the internet or on the Better Bricks website. We'll talk about that in a moment. Also, a lot of switchboards or switchgear manufacturers have built-in systems with metering already on those, and some of those meters can have a pulse output put on them to provide it out to your energy management system. Or if you don't have any of these, you can install all your own meters and devices and collect that data yourself. Here's an example of how the utilities collect interval data for their use. Through either their electric meter or the gas meter, or possibly in some cases some sub-meters for load research, the utilities will typically have a system that will collect the data while the meter reader comes down and downloads it when they visit the site once a month. But also they may have either a phone line, a pager system, a radio, or a cell phone signal that takes the data and sends it to the data collection system. The data collection system will then put this data onto an internal or external internet server, can be accessed by the customer via a computer using the internet or specific software. Many services will also take weather data and provide that into the external server so that customers may track their energy usage along with weather data. If you choose another type of system that's not using what the utility has, as you can see, this switchboard meter has some visual readout displays, but also it can have a pulse output that goes out to a data recorder. That data recorder will provide the data to the data collection system through either the switchboard pulses or a pulse output possibly from the utility meter. And then again, the information can be accessed via a computer over the internet through your browser or specific software. This is the end of the Interpreting Electric Meter Data, Session 3. what is interval data, and how do you get it. If you haven't already, please go to the Better Bricks website and go through the other 4 parts of the training.